What's up, everybody? In this video, we're going to be covering USACO's 2022 open contest at the bronze level, problem number 3, Alchemy. Always keen to learn new hobbies, Bessie the cow is learning how to transform metals. She has AI, where AI is between 0 and 10 to the 4th units of metal I, for 1 less than equal to I, less than equal to N, less than equal to 100. Okay, hold on. So what's N? They haven't mentioned N yet. We have some number of units of metal, I, for 1 to I to N. We're gonna have to come back to that. N. We're gonna start that over. What's up, everybody? In this video, we're gonna be covering USACO's 2022 open contest at the bronze level, problem number 3, Alchemy. Always keen to learn new hobbies, Bessie the cow is learning how to transform metals. She has AI, where AI is between 0 and 10 to the 4th units of metal I, for 1 is less than equal to I, less than equal to N, less than equal to 100. That's worded a little awkwardly, but basically what they're saying is N is how many types of metals. That's not really specified. And N is how many types of metal there are. So say, like, for example, there are 4 types of metal. Then my number of them are A1, A2, that's the amount, I'm guessing, of how much of each kind of metal I have, 1, 2, 3, and 4. So if N was equal to 4, indicating that I have 4 types of metal, then A1 would be how much of metal 1 I have. So I could have like maybe 4 of metal 1, 2 of metal 2, 3 of metal 3, and 0 of metal 4. In that case, then A1 is 4, A2 is 2, A3 is 3, and A4 is 0, just for example. What they're specifying is that the number of units of each metal is at most 10 to the 4th, which is 1, 2, 3, 4, 10,000, and that the number of different kinds of metal is at most 100. And then I, of course, is going to have to be less than the number of types of metal we have. So AI basically is going to run up to however many types of metal they have. We have up to 100 types of metal with up to 10,000 units of each type of metal. Furthermore, she knows K, between 1 and N recipes, where she can combine 1 unit each of several metals to make 1 unit of a metal with a higher number than all constituent metals. So all of the recipes will turn cheaper metals, if you consider to the left to be cheaper, into more expensive metals with a higher number. It is additionally guaranteed that for each metal, Bessie knows at most 1 recipe to make it. Okay, that's another really helpful thing, because then that means that if I know a recipe to make metal 4, there's only going to be 1 possible recipe that makes metal 4. And it's going to only take 1 of each of the ingredients. We don't have to worry about having 3 of one kind of ingredient and 2 of another, for example. Compute the maximum number of units of metal N Bessie can possibly have after some series of transformations. So basically metal N then is, again, the last metal. This is the final metal in this case. We want to try and make as much of that metal as possible. And we want to do so by using our recipes to combine the lesser metals into better metals. Every target metal can only be made one way, but may be used in, I have to check the test cases, but I think that may be usable in different recipes. So whereas if I say I want to make metal 4, I only have 1 possible way to make it. If I say I currently own metal 1, that may be usable in different recipes. We'll have to double check that. Input format. Input arrives from the terminal, standard input, so basically typed into the console. First line contains N. Let's scroll down a bit so we can see the input here. So first line contains N, that's how many kinds of metal you have. So in this example, we have 5 different kinds of metal. Metal 1, metal 2, metal 3, metal 4, metal 5. And remember, our goal is to make as much of metal 5 as possible. The second line contains N integers AI. Remember, AI is the amount of each metal. So the amount of metal 1 is 2 of them. I have no of metal 2, 0 of metal 3. I have a single unit of metal 4, and then no metal 5. Third line contains K. Remember, K is how many recipes there are. So I have 3 recipes. And then the next K lines start with 2 integers, L and M. Okay, so like, for example, L would be 5, M would be 2. Followed by M integers. Okay, so this 2 is indicating how many integers there are. So 2 integers here, 1 is how many integers there are here. 1 means there's 1 integer there. The last M integers represent the constituent metals in the recipe that are used to form 1 unit of metal L. Okay, so I don't know why they chose KL, probably because it's at KLM. So L is basically your target metal to make. So what that's indicating here is I've got a 5 here, which indicates that I can make metal number 5, which is what I'm trying to do, by using 2 different metals, 1 unit of each of 2 different metals. The first metal I need to use is 3, which is here. Next metal I need to use is 4, which is here. So I don't currently have any of metal 3, but if I did have some of metal 3, then I could use 1 unit of metal 3, 1 unit of metal 4 in order to make a unit of metal 5. We have a way to make metal 2 using 1 metal, which is namely metal 1, that's this metal right here. And we have a way to make metal 3, which is the one that we're currently missing to make 5, using 1 metal, and that's metal 2. So I can turn metal 2 into metal 3, and then I can turn metal 3 and 4 into metal 5. And we have to do this in a somewhat efficient way without using, there's actually a recursive solution to this. The recursive solution doesn't work in Python, and you have to write it really tight to get it to work in Java and C++. So we're going to briefly talk about the recursive solution, but I'm going to show you the iterative solution because the iterative solution runs faster and works in all languages. Ultimately, what you're trying to do here is you're trying to figure out how do I make metal 5? And I have my recipes down here showing that I can make metal 5 out of 3 and 4. I can make metal 2 out of metal 1 and metal 3 out of metal 2. So essentially what you would be looking at if you did this recursively would be something like, to make metal 5, I want to try and call make metal 5. In order to make metal 5, I would have to have metal 3 and metal 4. If any of those I don't have, I would have to call make on whatever I'm missing. So I'd have to call make, for example, 3. And then in order to make metal 3, I would have to use whatever metal 3 requires, which is 2, which would be calling make 2. And then that would call make 1, or that would deduct from 1. And then the recursion would come out and I would make a unit of 5. But again, this won't work in Python. And you have to write it really, really tight to get it to work in Java and C++. The slightly easier solution is to do it iteratively. So your goal with doing it iteratively is to try and figure out, if I need to make one of unit 5, how do I iterate this way through my list of numbers and do whatever it needs to do in order to make metal 5? Take a minute to think about that. See if you can run over that on paper and figure out how to approach that. And then we'll talk about how to actually do this as an algorithm. And do that on this blank page here. Okay, so I have 1, 2, 3, 4, 5, 2, 0, 0, 1, 0. Let me move that over a little bit. Four, 5, 1, 0. All right. Okay, so what I would recommend doing is keep track of a second array, which is what you will currently need. And then as you work your way through figuring out what you need, you can use your formulas. I'm going to write the formulas down too, so I don't have to flip back and forth. I've got 5 from 2, 3, 5 is from, or from 3, 4. 5 is made out of 3 and 4. 2 is made out of 1. 3 is made out of 2. Okay, so your iterative solution keeps track of what you need. Right now, to start off with, I don't need anything. Now, my goal is to make a unit of 5. So I'm going to change my need for unit 5 to a 1. I need 1 unit of 5. I'm going to move my way this way to see what I need to do in order to do that. In order to have unit 5, a unit of 5, I need to have 1 unit of 3 and 1 unit of 4. And if I have 1 unit of 3 and 1 unit of 4, then I'll have a unit of 5. So what I'm going to do then is say, okay, so I've got my 1 here. I'm going to drop that down to 0. And then I'm going to make these both into 1s because that's a unit of 3 and a unit of 4. Unit of 3, unit of 4, because I don't have a unit of 5 yet. So I have to make a unit of 5. I could have a unit of 5 if I had a unit of 4 and I had a unit of 3. If I had a unit of 4 and I had a unit of 3, then I wouldn't need a unit of 5 because I could make a unit of 5. That's ultimately what we're trying to do. We're trying to figure out, how do I make this number up top here go up? And in order to make it go up, if I'm trying to count how many units of n I have, if I want to make a unit of n, then I would need to have a unit of n. Currently, if I look here, I have a 0. Now, if, for example, let's just go ahead and alter these starting data. If, for example, I had 2 units of 5 to start with, then what I would do is I would say, okay, 0, 0, 0. I don't need anything. So I want to have a unit of 1. So I'm going to change a unit of 5. So I'm going to change that to 1. I check what I need against what I have. In this case, I have a unit of 5. So I could count 1 and I could subtract 1 from each of these. This will then drop down to 1. This will then drop down to 0. And then we've got a count of 1. And then next, I'm going to try and get another unit of 1. So I need another unit of 5. I have a unit of 5, so I can subtract 1 from that. That would be a 0. And then that would become 0. And then that gets us to where the data starts at. But that would be the count of 2. So assuming we don't have any units of 5, what our procedure looks like is if we need a unit of 5, then we have to work our way to the left using our recipes, figuring out what do we have to do in order to have a unit of 5. I want to make units of metal number 5, and I don't have any units of metal number 5 currently. In order to do that, then I look at my recipes and I say, okay, I can make a unit of 5 out of 3 and 4. If I had a unit of 3 and a unit of 4, I'm going to add 1 to each of those. If I had a unit of 3 and a unit of 4, 1, 1, then I would not need a unit of 5 because I could make a unit of 5. So that becomes a 0. Working my way to the left, I need a unit of 4. I currently have a unit of 4, so I'm just going to subtract that. I don't have to do anything. Same as when I was consuming the 5s. I subtract the unit of 4. I no longer have units of 4, but I no longer need units of 4. Moving my way this way, that shows that as long as I could get a unit of 3, I could have a unit of metal 5. In order to have a unit of metal 3, I look at my recipes, I would need a unit of metal 2. I don't currently have any units of metal 3, so I'm going to say, well, if I had a unit of 2, I would no longer need a unit of 3. That becomes a 0. So now I have a unit of 2. Now I need a unit of 2, but I don't have any units of 2 either. So once again, looking at my recipes, I could make units of 2 if I had metal 1. So if I need metal 1, but if I had metal 1, I would no longer need metal 2. That becomes a 0, and I keep iterating that way. I get to here, I need a unit of 1. Now, if I had a unit of this metal, I know that I can make a unit of 5. And I do, in fact, have a unit of that metal. So I can subtract 1 from that. That becomes 1. I no longer need any metal. Here, that becomes 0. I continue iterating this way. If I can make it all the way to the left, then that means that I've got a unit of 5. So now I'm going to do plus 1. That now is 1 unit of metal 5. I can start this over, run it again. So now I need another unit of metal 5. 1. In order to have a unit of metal 5, I would need, according to the recipe, a unit of metal 3 and 4. So we'll put a unit of metal 3 and 4. And then if I had a metal of 3 and 4, I would no longer need a unit of 5. And now I can iterate this way. I need a unit of 4. In order to have a unit of 4, I would need to be able to make a unit of 4. I have no recipes for metal 4. I need metal 4. I cannot make metal 4, which means I cannot make a unit of 5, which means we are done. And 1 is the amount of metal I was able to make. We'll look at that. And then the sample output is in fact 1. Now, this algorithm works all the way up. So essentially, let's go back here. Let's try it with a larger number of metals just to kind of fiddle with this. Maybe put another recipe. I'm going to say that I have a recipe for 4 that's going to be using metals 1 and 3. In addition, I'm going to have significantly more of metal 1 to start. I'm going to have actually more of all these metals to start. Let's have 3, 2, 4, 1, and 2. Okay. Slightly more complicated test data. So in the beginning, I don't need any metals. In the beginning, I have 3 of unit 1, metal 1. I have 2 of metal 2, 4 of metal 3, 1 of metal 4, 2 of metal 5. In addition, I've added a recipe. I can make 4 out of metals 1 and 3. Starting from the beginning, my count is 0. I need a unit of metal 1. Okay, so I need a unit of metal 1. Because I need a unit of metal 1, I have a unit of metal 1. I have 2 units of metal 1. So my count goes up by 1. 1, and then that's going to subtract 1, which brings it down to 1, and brings my need down to 0. Because now I no longer need metal 5 because I had metal 5. Once again, I'm going to run through again, starting from this side. I'm going to say that I need a unit of metal 5. I currently have a unit of metal 5, so I'm going to subtract 1 from both. That's going to become 0 and 0, brings my count up to 2. All right, I need another unit of metal 5. 1. In order to have metal 5, I would need to have a unit of 3 and a unit of 4. So 3 and 4 both become 1. And if I had those, I would no longer need metal 5. So I go 0. Iterating to 4. I need a unit of 4. I already have a unit of 4, so I can subtract 1. And then that uses my unit of 4, but I no longer need it. Iterating to here, I have a unit of 3 as well, actually. So we're going to subtract 1 from here, bringing that down to 3. Subtract 1 from here, bringing that down to 0. I don't need any units 2. I don't need any units 1. I've completed the iteration, which means now I have another unit of 5. 3. All right, rolling back, I need another unit of metal 5. 1. So I don't have any of unit 5, so I'm going to have to use my recipe, which says I can make it out of 3 and 4. So then this is going to become, I need a unit of 3, I need a unit of 4, and now I no longer need a unit of 5. Moving this way, I need a unit of 4. I don't have any units of 4, but I added a new recipe for 1 and 3, which means I would need 1 unit of 1. I need an additional unit of 3, which brings this up to 2. But now I no longer need unit 4, because if I had those metals 1 and 3, I would have 4. Iterating further shows that I need 2 units of 3. I have that much, so I'm going to have 1 left here, and then this is going to go down to 0. Iterating further, I don't need any unit 2. I need a unit of metal 1, so it's going to go from 3 to 2, and then that's a 0, and now my count goes up by 1 again. Rolling back, I need a unit of metal 5. Again, just keep putting in that I need units. Iterating this way, unit of metal 5 requires 3 and 4, 1 and 1 and 0. I need a unit of 4, which I don't have. Units of 4 require 1 and 3, which again is going to make that equal to 1 and 2. But then this becomes 0. Iterating here, I need 2 units of 3. I only have 1 unit of 3, so I can subtract 1, making that a 0, bringing me down to needing only 1 unit of 3. But now I still need that unit of 3. I can make a unit of 3 out of a unit of 2, according to my recipe. So then my need here is going to go up to 1. My need here is going to go down to 0. I iterate further. I have a unit of 2. So I'm going to subtract 1 from this, making that 1. I have a unit of 1. Subtracting 1 from that, making that 1. And then these now are both 0. 0 and 0. I've made it to the end here, which means now I have another one. Made a 5th unit. This will be the last pass here. Need a unit of 5, which means I need a unit of 4 and 3. 4 and 3. I need a unit of 4, which means I need a unit of 1 and 3, which means this is going to go up here and here. That becomes 1. This becomes 2. This is going to become 0. Iterating on. I need units of 3. I have no units of 3, but I can make them out of units of 2. So this is going to move that over here. This is going to become 2. This is going to become 0. Units 2. I have 1 currently, so I can use it. That'll be 0. And this would go down to needing 1. I need still 1 more unit of 2, which I can make out of 1 according to the recipe. So then this is going to go up to 2 units of 1 that I need, meaning I no longer need units of 2. I get here, and oh, I don't have enough. If I had 1 more unit of 1, then I'd be able to make a 6th unit of metal number 5. But because I need 2 and I only have 1, I can only fill the 1, which brings us down to 0. 0 units of 1. But then I still need a unit of metal 1. I don't have any recipes to make metal 1, which means we're done, and I was able to make 5. So that's your algorithm. And again, the iterative solution will run plenty quick enough because of the fact that your, let me see those numbers. The number of metals is only 100, so it takes 100 steps through here to make every recipe. We also know K recipes, which is between 1 to N, which means that at most you're going to have 100 recipes. And then the number of units is at most how many times things have to be deducted for each unit. But essentially you've got 10 to the 4th times 10 squared times 10 squared, I think is what the complexity comes out to, which is going to be around 10 to the 8th. So you're well within time complexity either way. Alrighty, so that's the algorithm, and good luck coding it. I'll talk to you in the next one.